Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ant. In this tutorial, we'll go through these combined science. This is basically 3 sciences combined into one subject. So I'll be specifically going through this organic chemistry section. So in this first question, so in this methane and butane, so we can see from the name ANE and ANE, this belongs to the alkanes, ALKANE homologous series. They have got CnH2n plus 2. This is called their general formula. So N is just the number of carbon. When you start with the meth there, N equal to 1. When you start with but, N equal to 4. What we are told here is that methane boils at minus 162 degrees Celsius, butane boils at minus 1 degree Celsius. If we do a number scale in terms of temperature, going from the lower temperature minus 162, minus 1 is actually bigger or higher than minus 162. So we can see that butane has a higher boiling point than methane. So in terms of molecular size, number 1. In terms of intermolecular attractive forces, number 2. These are part of year 9 states of matter topic, and also structure and bonding topic. So they are all related all the way to year 9 stuff. So number 1, we can say that butane has bigger surface area, so it is a bigger molecule. So this relates to the bigger molecular size. So therefore, bigger molecular size is a bigger molecule, a larger molecule than methane. So that is number 1. And then number 2, we can also say, therefore, the intermolecular forces. Inter means in between. When you have inter-school competition, that means between the school. Intermolecular forces of attraction, or you can say intermolecular attractive forces. So this is between the molecules. So between the butane are stronger because we are comparing. So these are stronger than in between. Methane, therefore we require more energy. So if we require more energy to break, therefore you need higher temperature to break. Therefore you would have a higher boiling point. These are all part of year 9 structure and bonding, where they would have simple covalent structure. In the next we have the question, we have ethene. This is CnH2n. This is part of the alkene homologous series there, where they have carbon-carbon double bond as the functional group there. So we get alkenes, we get this small chain alkene by doing something to the long chain hydrocarbons. This is called cracking. So cracking is done in industry by using high temperature. So very high temperature, around 500 degrees Celsius. You would also need a catalyst. So there isn't a need for you to know what the catalyst is in the syllabus, but you do need to know that this cracking is done in the presence of catalyst and very high temperature. So this catalyst is used in this process. So what is happening? What change do you have to the catalyst at the end of reaction? This is from year 10. Year 10, rate of reaction. In the topic rate of reaction, we talk about a catalyst is used in the reaction to make reaction faster. To make reaction go faster, but itself will not change physically. So it will not change. It will not change chemically. So chemically, it remains unchanged at the end of reaction. So at the end of reaction, it remains chemically unchanged. So you can say it will not change chemically, or you can say it remains chemically unchanged as stated in the syllabus from year 10. Year 10, rate of reaction. So we had already gone through that. Catalyst remains chemically unchanged at the end of reaction. Part C, carbon dioxide is produced during the complete combustion of hydrocarbons. Hydrocarbon contains only carbon and hydrogen atoms only. So when you burn them, you're supposed to get just carbon dioxide and also water. So you do get carbon dioxide. The formula for carbon dioxide is CO2. These are from year 9. Year 9 covalent bonding. In the syllabus, you were expected to draw the dot and cross where the carbon form 2 covalent bond to the oxygen, but carbon in group 4 with 4 electronic configuration. 4 electrons in the outer shell. So carbon needs to share 1, 2, 3, and 4 electrons. Therefore, to complete the outer shell, to draw the dot and cross, cross from the carbon, and then we can draw in the oxygen, dot oxygen. But oxygen with 6 electronic configurations, it shares 2 electrons. That means we still have 4 more in the outer shell. These are called dot and cross diagram. We need to complete the outer shell electrons, and that is basically what the next question is asking us to do. So carbon there will share 2 electrons to each oxygen. So if I use cross for carbon, then I have to use dot for oxygen. But if I use dot for carbon, then I have to use cross for oxygen. So you can use cross here for carbon and dot for oxygen, or could be the other way around. If I use dot for carbon, I have to use cross for oxygen, but I must complete my outer shell based on the electronic configurations. So they don't mention this question, but typically you gotta draw outer shell electrons, so no need to talk about what happened to the inner shell electrons because they are not used in bonding. So carbon dioxide is CO2. It is produced during the complete combustion of hydrocarbon. This is part of Year 10 Environmental Chemistry. Year 10 Environmental Chemistry, complete combustion hydrocarbon give you carbon dioxide, which is a greenhouse gas. It can cause global warming, just like methane, CH4. So what is the other product? So here they want formula, which is number 1. They want the other product. You get carbon dioxide and water. So the formula of water is actually H2O, and you cannot write down water because they want the formula according to the question there. So what is the type of chemical bond that forms between oxygen, which is a non-metal, and sodium, which is a metal? So you have sodium, which is a group 1 metal, 281 electronic configuration, oxygen 26 electronic configuration. So altogether, the metal will lose the electrons, and then you will get Na plus with a fully filled outer shell, and then you will get O2 minus with a 28, which is a fully filled outer shell, but you gain electrons. That means you gained negative charge, but then altogether you do need 2 of these electrons because this can only donate 1, so you need another sodium. Therefore altogether you will get Na plus, O2 minus, 1 and 2 based on the charges of the ions. Year 9 chemical formula. Year 9 chemical formula. Valency is your combining power based on the charges of your ions. So sodium in group 1 have a valency of 1. Oxygen gain 2 electrons to complete the outer shell. So the valency is 2 there. We do cross multiply. This is lowest common multiple from primary school mathematics, LCM. It means you need 2 of this Na plus like that, and O2 minus, so that you get Na2O. This is known as sodium oxide, or oxygen combined with sodium. What you get is what you call an ionic bond, because this is formed between a metal and a non-metal. So this is a group 1 metal, and this is a group 6 non-metal, so they form Na2O. Lowest common multiple of these charges. The charges have to cancel out. +1 + 1 is +2. 2 of them cancel out 1 of these -2. Ionic compound has ionic bond there, unlike covalent bond, sharing of electrons in the previous question. This is ionic bond in ionic compound, sodium oxide. In this question number 2, we have formula of methanol. Methanol structure is from year 9. Year 9 structure and bonding under covalent bonding in the dot and cross diagram of the syllabus. So they are actually something which you have done a while ago. Why is it not a hydrocarbon? So we have to define what is hydrocarbon based on the syllabus definition. So what do we know about hydrocarbon? So hydrocarbon contains only hydrogen and also carbon atoms only. So it doesn't contain any other atoms except for hydrogen and carbon. And then we can say CH3OH has an oxygen atom, so therefore not hydrocarbon. So what is hydrocarbon? And therefore if it doesn't follow the definition, it doesn't work that way. Next, we have the question is straight from year 9, structure and bonding, as I mentioned there. So if I try and draw, this is methanol, so CH3OH. If I try to draw the display formula first, hydrogen forms single covalent bond because hydrogen just want to share one electron to complete outer shell. Carbon with 2-4 electronic configuration, 4 electrons in the outer shell. They want to share 4 electrons to complete outer shell. Therefore, they form 4 covalent bonds maximum. This carbon form 1, 2, 3 covalent bond. Not happy. Bonded to oxygen. Oxygen in group 6. 6 electrons in the outer shell. Forms 2 covalent bonds. Only form 1 there. Not happy. We can see now CH3OH. CH3OH like that. And now each of these lines is a single covalent bond. So 1 electron from hydrogen, 1 electron from carbon. So I could draw like this, and like this. These are for the CH single covalent bond. Single covalent bond. 1 electron from hydrogen, 1 electron from carbon. So if I try to say that is cross, and we're saying that if dot is also oxygen, so that is in between carbon and oxygen, a single covalent bond there. So 1 electron from carbon, 1 electron from oxygen. So oxygen again forms a single covalent bond to the hydrogen like that. But oxygen started out with 6 electrons in the outer shell. So what I could do is I could just have another 4 more electrons because I only share 2 electrons out of 6. So that means I still have 4 more electrons on the oxygen which are not used for covalent bonding there. Now explain why a molecule of methanol contains only covalent bonds. What is the criteria? What is the characteristic? What actually forms covalent bond? Okay, so we can say that CH3OH methanol, as given in the question earlier, only contains nonmetals. So what are the nonmetals? We have carbon, C. We have hydrogen, H. We have oxygen, which is the O. So nonmetals and nonmetals only form covalent bond with each other. So nonmetals share electrons with each other. That means nonmetals form covalent bonds with nonmetals. If you have metal and nonmetal, then you have ionic bond. Now methanol is used as a fuel because it burns in oxygen. Complete combustion of this methanol will give you CO2 and H2O. These are part of environmental chemistry. When you do complete combustion of organic compound, typically you will get carbon dioxide and water. So these are not word equations. These are balanced chemical equations. They are part of year 9. Balancing chemical equations is part of year 9 chemistry in the combined science curriculum. So we'll burn it in oxygen, we'll get carbon dioxide, we will get water. They have put a 2 in front there. 2 in front means you have 2 molecules of this CH3OH. So there is 1 carbon in CH3OH, 1 carbon, but you have 2 molecules of it. So altogether you got 2 carbon atoms. So 2 times carbon atoms there. So therefore, here I must have 2 CO2. I cannot change the formula of CO2. They are governed by year 9 structure and bonding. If you draw CO2, year 9 structure and bonding, dot and cross, covalent bonding. On the other hand, we can look at the hydrogen atoms. 3 plus 1 is 4 hydrogen atoms in one molecule. You can see 1, 2, 3, and 4 hydrogen atom in one molecule. You have 2 of them, so you have 2 times 4, which is 8 hydrogen atoms. We have 2 hydrogen atoms in one water. We need 8 to balance the equation on the right. Something multiplied by 2 give you 8. This is simple primary school mathematics. 4 times 2 is 8. Next up, we have 2 times 2, which is 4 oxygen atoms on the CO2. And we have got 1 oxygen in 1 water. We have 4 water. So 4 times 1, which is another 4 oxygen atoms. Balancing equation, total up the atoms on the left and the right. We have 8 oxygen atoms on the right. Therefore, we need 8 oxygen atoms on the left. But we have molecule, which we cannot change the formula. So what we can do is we have to put 4 in front. 4 times 2 give me 8 there. During the combustion of methanol, we get more carbon dioxide in the atmosphere. What is the effect of this increase? This is part of year 10 environmental chemistry part of the syllabus. So carbon dioxide is a greenhouse gas. So what does a greenhouse gas do? So the greenhouse gas will result in global warming. So therefore, it can cause global warming. So very obvious from the term, global warming means the whole world will get hotter, and therefore, it can kill crops and animals and cause flooding due to increased sea level of seawater around the world. Question number 3, we have this fractional distillation of crude oil mixture. So this is how we get our different petroleum products from crude oil that we get from the ground. This process is called fractional distillation, and it works because of different boiling points. These are from year 9 separation techniques. Year 9 separation techniques taught you about fractional distillation. So this was year 9, first year out of the 3-year curriculum. So we have the petroleum that we heat it up. So this is to boil the different mixture that have different boiling points, and they get collected as they get condensed down. So condensed to be collected. 2 processes in distillation. You have the boiling, and then you have the condensation. Overall, we call that distillation. Fraction P and fraction Q contain different compounds. Q is at the bottom, P is on the top. So as you go down the column, as you go further down the fractionating column or the fractionating tower, what we get is longer carbon chain. We get bigger molecule. So the molecule get bigger and bigger. What else can I say? We also have stronger intermolecular forces. That means between the molecule, there are stronger intermolecular forces. Therefore, we can say the boiling point and the melting point would increase. Now, describe 2 of the differences between the compounds in those 2 fractions. I've listed a couple. So fraction P, which is further on top, so further up in the column, further on top of Q, has shorter carbon chain. So they contain carbon, they are hydrocarbons, so shorter carbon chain. You can also talk about smaller molecule. So therefore, it's a smaller molecule than fraction Q, which is at the bottom. Okay, so next up, we can also talk about their different boiling point. So fraction P on top would be the one that boil first. So it would have lower boiling point. Lower boiling point means easier to boil. So therefore, easier to boil. Another English word that can try to trick you means is more volatile. Volatile means easy to boil. More volatile means easier to boil, therefore lower boiling point. Then fraction Q, which is at the bottom. So there are more than one of these answers which you could have written down. There are a lot more, such as viscosity, such as density. So those are all acceptable as well if you have gotten the correct concept. So you can talk about density, viscosity as well. Now name this process Y. What is process Y? Process Y produces short chain alkene from longer chain alkane molecules. So long chain becomes short chain, which are more valuable. So that is what you call cracking. Cracking requires very high temperature. So temperature required will be around 500 degrees Celsius. You also need a catalyst in order to speed up the rate of reaction to make it faster. So this process is known as cracking. Part C, the rate of reaction in process Y. This is cracking. As mentioned, you use it at high temperature. You do it at a very high temperature, 500 degrees Celsius, and you have a catalyst to speed up the rate of reaction. Without itself, chemically change at the end of reaction as stated in the rate of reaction topic. Why is it used in the form of a powder? This is straight out of rate of reaction topic in the syllabus. So powdered form has larger surface area. This is larger surface area to do what? This is for reacting particles to collide with. So that means you collide more frequently. To collide with more frequently. And if you collide more frequently, therefore, you get faster rate of reaction. Or you can say rate of reaction increases there. Next up, how does a high temperature increases the rate of reaction? You must talk about kinetic particle theory. Kinetic is to do with kinetic energy. So your kinetic energy is related to temperature as stated in the rate of reaction topic. As temperature increases, what we can say is that your reacting particles or the particles that collide together, they will gain more kinetic energy. So we have to focus on the term kinetic energy as the question asks us to talk about kinetic particle theory in chemistry. So when you gain more kinetic energy, so therefore meaning the reacting particles can collide more frequently. And when they collide more frequently, therefore a faster rate of reaction or the rate of reaction would increase there. Next up, bromine is added to two different samples. So we use bromine to differentiate, to tell apart, to distinguish. So it means tell the difference between alkane versus alkene. Because when you have alkene carbon-carbon double bond, you can decolorize the bromine. That means the Br can add, you can do addition across carbon-carbon double bond of alkenes. So this one has positive effect, this one has no effect. So no effect will be alkane, will have an effect will be alkene with the carbon-carbon double bond there. Part E, combustion of hydrocarbons. This gas give lime water milky. They want the formula of the gas. The gas is definitely carbon dioxide. This is from year 10. Year 10, test for gases as part of experimental chemistry. They want the formula, which is part of year 9. Year 9, covalent bonding under dot and cross, as well as covalent bonding chemical formula there. Now this must be a complete combustion because you get carbon dioxide. environmental chemistry said that if you get incomplete combustion, then you will get carbon monoxide, which is single oxygen, and carbon monoxide, CO, is toxic. CO2, carbon dioxide, come from complete combustion of hydrocarbons, and that means you can be a greenhouse gas, and that is the concern meaning what is the harmful effect, what is the outcome which are dangerous, what is the harmful consequence, is that CO2, or you can say carbon dioxide, is a greenhouse gas. So what does the greenhouse gas do? It can cause global warming. So therefore, it causes global warming. The whole world is getting hotter. So sea level will rise, crops will die, people's lifestyle will be destroyed then. And that's it really for this work 1 tutorial for this combined science organic chemistry 14 to 16 years old curriculum. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected.